Exercise 40, question 2. Rearrange this formula for little f. I'll go through the solutions. Two possible ways to go about doing this, as in question number 1, which comes up with the two solutions given in the text. At any point you could pause and see if you can carry on and finish. At the end, I'm going to ask you to have a go at rearranging the formula for capital F. So let's look at the solution. First job I would suggest would be to multiply both sides by L. If we look at the formula, if I want to get little f on its own, then it's inside a bracket, and then that bracket has been times by 3 and divided by L. So divide by L would get rid of that. So multiplying both sides by L equals 3f minus f. Now the two solutions that appear in the text will come from the two ways we can proceed from here. One way would be to leave the right hand side as it is without expanding out and just divide both sides by 3. So let's carry on from there and see if you can work out the solution. The other way to go would be to multiply out the right hand side. And what I'll do is I'll go through both methods and you can maybe have a go at them. So first of all, let's try leaving the bracket on the right hand side. So that means the whole term, capital F minus little f, has been multiplied by 3. So divide both sides by 3 and we get AL over 3 equals f minus f. So now we're trying to isolate little f. It's negative, so what do we do with that? And then carry on from there, see if you can finish it. So if it's negative, add it to both sides. So little f plus AL over 3 equals capital F. And then finally, to get little f on its own, subtract AL over 3 for both sides, which gives one of the solutions in the textbook. Going the other way, multiply out the right hand side, so we get AL equals 3f minus 3f. Remember, after the term in getting little f on its own, so what we do at this point, carry on, see if you can isolate little f. So the term involving the small case f is negative, so add it to both sides. Now subtract AL from both sides, so 3f equals 3f minus AL, and then finally divide both sides by little f. By 3. So f equals 3f minus AL all over 3. Now finally, we need to just show that they are the same. So looking at the right hand side, can we show that that's the same as the left hand side? Looking at the left hand side, can we show that's the same as the right hand side? Well, looking at the right hand side first, algebraically, I would split both terms on the right hand side and write it as f equals 3f over 3 minus AL over 3. Now looking at that, we can see in the first term on the right hand side, 3's cancel, so little f equals f minus AL over 3, which is the solution we had the first way. Going to the left hand side, how can we get this, prove that this formula here is the same as the formula which is the answer on the right hand side? How do we show that? It's slightly more awkward to show that. What we need is a common denominator, so I need both of these terms on the right hand side to have the same denominator, i.e. 3. So looking just at this term, if I multiply and divide by 3, it'll have that denominator. So 3f over 3 minus AL over 3. this procedure of making a common denominator is very important for later algebraic methods, so it's worth seeing how this works. Now, because we've got a common denominator, I can write that as 3f minus al all over 3, and it's the same as the other solution. So they are the same solution. Again, it doesn't matter which way you write the solution, but it's important to see that they are the same. Okay, so now, just as a little extra exercise, take this original formula and rearrange it for capital F. Write the two solutions and show that they are the same. So similar procedure to what I've just done here. I'll pause at this point and you can have a go. The solution sheet follows on the next slide. Okay, so multiply both sides by L. And now we've got the two ways to go. So we can either leave the right-hand side as it is without expanding out the brackets, so divide both sides by 3 and go from there, or we can multiply out the brackets. Try both ways, get the solutions and show they're the same. I'm going to stop the recording at this point, but the notes show the solution.